Walaikum salam wa rahmatullah. Dr. Dr. Kamal Abdurrahim. How are you, sir? How's everything going? You are welcome to another edition of the second day of our training. So thank you very much as we get ready for the day's job.
Hello, everyone. Good morning, good afternoon, and good evening, irrespective of your station. We are welcome back to the program today, which is the last leg of the track 1 of 2026 ASOM AI Summer Bootcamp. As rightly said yesterday, today we'll be having a session, and the session starts, or it has already started, by 2:30 Nigerian time, and it will last for 1 hour 30 minutes. By 4 o'clock. We'll be bringing it to the short. While we are set for the program, I want to sincerely welcome us back. I'm slightly checking the number of participants on board. We have 15, and I know the time is not really there for us today. I think I will just call on our professor who has been on ground to begin the program right away. In the course of the program, I will send in the attendance list and some of the other resources that we might need for registration. Meanwhile, the summer school for this 2025 is of 2 tracks, which we are ending the track 1 today. And this is for everybody, for beginner. I have never known anything about AI. You are highly welcome for this one, which you are already here. But the second one is a little bit an advance, but the way God has endowed our professor, he has the capability of taking you through, of even the advance, giving you the prerequisite, and at the same time, you will be standing well, as rightly said by the academia, that the student is on good standing. You might be standing well when you are even coming for the first time for the second track. I'm only using this opportunity to inform us that we will be having the second track by next week. For those of us who registered for the 2 tracks together, that is fantastic. And for those of us that we just want to see what is being done here, we have seen, and we are still seeing to the end of this program today. But we also encourage you, if you know you have learned 1 or 2 things from this track, you are encouraged to also register for the second track for the coming weekend, for this coming weekend. The information for the registration and everything is on the flyer already shared on our platforms, and as time goes on, we continue to share it. Meanwhile, all the resources used yesterday, they are already deposited on the platform created for the track 1. And if you have any issue, please do not hesitate to call our attention. Appreciation to those people that called our attention to 1 or 2 things yesterday. That is highly appreciated, and I believe we have corrected, or we have done what we should have done on those issues that our attention was called to. Well, as the program goes on, I will be making all the necessary announcements as they cross my way. Once again, I sincerely welcome you to the last session of the track 1. And our professor, please, I'm sorry for taking your time. The floor has been yielded to you. Thanks so much.
Oh, good afternoon, everybody, and then you are welcome to the day 2 of our training for the track 1. And we appreciate the coordinators who are working around the club behind the scene, was making this a reality, starting from Professor Daniel Palara, Dr. Tajudeen Mujisola, I just spoken with you, and Dr. Ismail Mustafa, July, all the coordinators working behind the scene towards ensuring the success of this program. We appreciate you all, and we appreciate also the participants for joining us in this year's edition. So as my screen is showing, selected machine learning concepts and frameworks. So as was stated yesterday, it is humanly impossible to cover all what you need to know about machine learning within 2 days, even if it has to be 2 full days. However, we quickly also look into few concepts that I think that you need to be aware of while you continue to dive deeper into the learning by being in touch with us through our YouTube channel. And our weekly Saturday program is also meant for you to deepen what you have learned during the course of this training So you're always welcome, as the coordinator have stated. As you are learning, come across anything, feel free. The live session on Saturday is for you. You can interact and ask questions, clarify things. And when you run into challenges and you want to solve it as soon as possible, you're also very much welcome to private chat us so that we can hopefully be of help and support for you. So wish you a very successful experience, an interesting experience as you learn and try to implement machine learning and AI in your various field of endeavor. Now, a quick one. Again, I remind us of what we did yesterday. Remember, I mentioned there's this building block, which I called iterative. So you can always go back. See, machine learning model is an iterative process. It's very, very important for us to always note this. So start here, especially the modified one that I call modified iterative machine learning modeling framework to support let the data speak. Don't forget that don't stay too much at this point. It used to be the old scheme. People spend 70 to 60 to 70% of their time doing preprocessing before they go into modeling. Unfortunately, some of those preprocessing are actually supposed to be optional. So you may end up actually mutilating your data unknowingly. So the let the data speak idea is now encouraging us to say that just do the compulsory preprocessing that will make your data to be ready for modeling. Even sometimes treating missing value may become optional if you are working with decision tree family. Because decision tree family of algorithms, they have inbuilt mechanism for handling missing value. It means as your data is arriving, even though there's missing value, plug in into decision tree or any other family of decision tree algorithm, do the modeling, and then check the performance. Hooray, everything is fine, wonderful, fantastic outcome, you're good to go. And then say you want to do something, the model very to make it faster, you go back, do feature selection and the likes. So always have that freedom to go back. Don't forget. In the first going back here, these are some of the stuff we can do. You can do hyperparameter optimization. That's why it's compulsory. Compulsory. You cannot declare that an algorithm is not good if you didn't do the hyperparameter, because some people do make this mistake. They just use the default SVM and they use the default decision tree, and they are getting excellent result for decision tree, the default value, but support vector machine is not getting excellent result. They declare that support vector machine is not good for that data. No, it's not correct. Before you can declare that an algorithm is not able to model your data, you must do what we call hyperparameter tuning. It's compulsory. It's one of the stuff that reviewers will be looking for in your reports. So pay attention to that. So hyperparameter tuning is very much compulsory. Do it because we do more comparison. You cannot just compare two algorithms because you are fortunate the default parameter for one algorithm is excellent, that one, the other one is not excellent. You can't declare that this is better until you have carried out the proper hyperparameter tuning on each algorithm before you can declare that, okay, this is better than this. After that, after the hyperparameter, you may also change the algorithm to another one. You may make ensemble, which I hope we are going to have the opportunity to quickly go through, hopefully before the end of the program today. So you can always go back, performance improvement, we are analysis again. I mean, feature engineering, where you can do any of those things here. Feature selection, PCA, principal component analysis, we answer questions regarding it yesterday. You may also do normalize your data, log transformation of your data, anything that can you can work on your data to make it better, to be able to provide the insight that you are looking for. However, don't forget, original data must be modeled before you start trying all those kind of stuff. Because sometimes the original data is having the insight you are looking for originally. So why going through the entire process of excessive pre-processing only to find out that what you are looking for is already in the original data set? Talking from experience, we've had cases like this where people work extensively on pre-processing. When then I just look at the data set, I say, this data doesn't look like original data. Where's the original data? Because the data has been normalized, it has been transformed, the original data. They brought it, I said, okay, start again now. Let's see what the data is telling us. Luckily for them, they were able to get excellent results from the original data set. So that is codifying for you the principle that I call let the data speak. Don't force your data on, don't force any algorithm on your data. Don't assume a particular algorithm will be good for your data. So pay attention to that. So the other preprocessing also you may have to do missing value treatment, outlier treatment. But as you are doing one, you are going to do modeling to see maybe you're already where you are going. When you do another one, you're going to have another model. And don't forget, whenever you modify your data, you may have to do another hyperparameter tuning because your data is not different. When you do PCA on your data set, you have to do another hyperparameter tuning because it's a different data entirely now. Let's pay attention to that also. And that was why we have what we call multi-channel pipeline. Instead of using only one single pipeline, like people are doing, they have several preprocessing in a single line. No, have multi-channel pipeline. This pipeline value treatment. This pipeline is having missing value treatment, feature selection, plus outlier detection. So try different pipelines, and then finally you can go out with the one that is giving you the best possible result. Let's pay attention to that. Okay, so this is, and the preprocessing part of it, I just mentioned, sometimes you do the preprocessing here, you're also going to modeling, you check the performance, you can always go back. Don't do too much preprocessing if it's not necessary. Some of the preprocessing activities are optional. Please take note of this. So let's look at a couple of the preprocessing we have. Yeah. See, in preprocessing, preprocess the data. You see, the measure of data quality, a multidimensional view. To look at the accuracy. Is the data accurate? Is it correct? Is it wrong? Even while typing the data in, maybe they made mistake where the data is coming from. Completeness. Is the data complete? Maybe some are missing. Consistency. Is there any conflicting data set? Here you have the date of birth. There is an instance. Date of birth is here. In front, you see age. Somebody that was written to be 2020. Date of birth, 2020. For that patient, 2020. But when you see consistency in the data, these are some of the stuff we may have to handle in data preprocessing stage. But all this, like I said, first of all, let the original data speak. Model the original data. Then you see that, oh, it's not working. We are not getting good insight. Then we start going back to see what could be responsible. Because sometimes, even with some of these minor issues, the data may be robust to take care of everything and still is able to provide what you are looking for. So the data timeliness, is it updated? Is it current data? Do we really trust the correctness of the data? Interpretability, how easy the data can be understood and interpreted. The major tasks we do that we can actually engage in data processing, the data cleaning, filling the missing values. I already told you, even for missing value, it's not compulsory. You go and use decision tree family of algorithms that has the inbuilt mechanism for dealing with missing value. Which means you can still do your modeling without treating missing value. Sometimes you need to smooth the noisy data, identify or remove outliers, resolve inconsistency. All these, they are good, but then they are optional. Okay? So optional. So always let the data speak. Let the original data goes in, see what's the outcome. If it's hooray, everything is wonderful, inside everything perfectly done, that's wonderful. We have rare data set like that despite little issue here and there, they are still able to fire and provide the needed super excellent insights. So data integration of multiple files, database or data cubes. Sometimes you have data from multiple branches of your company or of your laboratory. You want to merge them together. Someone will do data reduction, like dimensionality reduction, numerosity reduction. This is where you reduce the number of features. This is when you reduce the number of instances of the data. So like PCA, I mentioned before, they're part of data transformation. Sometimes you can transform your data. You can normalize it. It is very, very common. Normalization is very common in everyday activity, but still, it's not compulsory. It's also optional. So first of all, use the normal data set, then come back and do the normalized data. Compare the result. Which one is giving you better result? That is what we mean by letting the data speak, so that you don't miss any possible opportunity to get the best possible result from your modeling. Otherwise, if you jump at a particular preprocessing and you didn't try the original data set, you may miss the important information. So in missing data treatment, so what is missing data? This is when your data is missing. What are the causes? It could be several causes. The person typing in, the hand just jumped, data entry clerk forgot to type it. So why do you require to carry out missing value treatment? And what are the methods? You see, it's a whole lot topic on its own. So make your life easier. We're just going to summarize it here today. And I will refer you to few of our well-curated videos on our YouTube channel that discuss missing value treatment. We explain in detail some of the methods you can use for missing value treatment when it becomes very necessary. See, let's say you have a data set. This is gender. This is gender. This is age. It's an Excel file. You see here, this dash here. This is male. This is female. Male. 64, 72, dash, 46. Sometimes we have this. The data is missing. That's what we mean by missing data. The data about a particular instance, this one instance number 1, 2, 3, 4. There can be many. Wait. Sometimes, so you see some parts of this information may be missing. And if there are missing values, yes, sometimes it can really affect your modeling. We describe some of the practical demonstration how it could affect it. But don't forget, let the original data speak first. So sometimes you have so many missing values. What are the means of treating them? In a summarized form, the best way to treat your missing value, number 1, is to go back to the source of the data. Go back to the source of the data and let them correct their mistake. This is the best way to undo missing value. You go back to the source. That data is coming from social agency. Go back there. Talk to them. Let that data entry clerk bring out the manual, the paper-based data. While typing in, oh, we made a mistake. It was supposed to be 45. We didn't put anything. But sometimes it may not be possible to go back because maybe the data is even from online. Maybe you went back to the company. They told, oh, this data was collected how many years ago? The clerk who did it already retired, so we cannot trace it. Then you go to the second option. Second option is where you're going to delete. Let's say you have one of the columns, missing value. It has so many missing value. is a column with the missing value is almost more than the available samples under that column. So you delete that column. You delete it. You remove it from your Excel sheet. That is one way of modeling it. One of these, the next method of correcting missing value. You delete that particular variable. But you can only do that if you have enough variables to deal with. If you're having only 2 variables, how can you delete one of them? You see, so when you have 15 variables and you have 3 or 4 of them that are having this problem of so many missing values in that column, you can afford to delete all those with huge number of missing values. Sometimes also, the missing value may be from maybe an instance. Missing value here, missing value, missing value. Out of maybe 15 variables, this sample is having missing value in almost 8 out of 15 variables. I can afford to delete this. Cancel it. Just delete that particular sample. Remove the instance from your data, provided you have enough data set. If you don't have enough data set, maybe they gave you only 10 samples. You cannot afford to delete from 10 samples because it's not even enough. But if you have 1,700, 10,000 samples, and now you have a sample that is having many missing value, you can afford to delete as many of them as possible. That is how you have the second stage, that is deletion, that is eliminating the instance or variables, that is the feature that is having so many missing value under there. The third level is what we call replacement. That is replacing missing value. Replacing missing value. That's the third level. Unfortunately, many people jump to this level. When they talk of missing value, they jump to this. It's not the way to do it. First of all, explore this option. We know in reality it may not be possible. Then go to this option. You have so many variables, you can afford to delete some of them. So many missing value under each samples, you can afford to delete them. The last option here is this, replacement. How do you replace? I'll find the mean of this value. Mean, find the average, 1, 2, 3. All the values that are present here, calculate the average. Use the average of that column to replace this missing value. Maybe the average is 37, 37.5. Every missing value in that column, 37.5, 37.5. This is how you replace it. You can use the mode, the most occurring number. You can also use the median. Just try to see which one will give me better modeling. Well, which method is better? Nobody can tell you. You have to always let the data speak. See, you may use a particular method today in your data, and using the mean may be the best for you. In another data set, it may be using the mode or standard deviation or any other statistical characteristic of the column. In cases like this, male, female, male, female, we can use the mode. The most occurring gender will be used to replace the one that is missing. Maybe out of these available ones, we have 2, maybe 15 males, and then maybe 10 females. Then every missing value, I treat it as male. Male. You see, that's how you treat missing value by replacement. Again, I refer you to that video. Just rise up. I believe one of the coordinators can actually search out the video on missing value treatment or preprocessing and paste it in this particular session chat so that they can easily locate it. I strongly recommend us, because time will not permit us to go to more details. Another very important thing that we do have to handle in our data is outlier detection and treatment. After missing value, outlier detection and treatment. What is an outlier? See, outlier is when you have values that are totally out of range. For instance, I'm modeling my year 1 undergraduate student. In their age, I found two 10 to 15 years. Under the age, the remaining one are 20, 21, 19, 18, 20. Then we can suspect that this 210, maybe they wanted to write 21, but mistakenly they pressed 0 unknowingly. This one, they wanted to write 21, they mistakenly pressed 5, making 215. 215 years in 100 level. In this age, even if old people are allowed to be in undergraduate, I don't think you have somebody who is 200 something years who will still be going to the university. In that case, we suspect that this is an outlier. That's what we mean by outlier. It's a value that is totally, extremely out of range in a data sample. The impact is huge because whenever you want to model your data, the data can confuse your algorithm because the dispersion is going to be huge. If you find the standard deviation, that big number from it to make it to be deviate, the standard deviation will be too much higher than normal. Because the standard deviation is supposed to be very small. 21, 19, 20, 21, 19. Most of the students are in the same age range in most cases. 18, maybe 17 in rare cases. But now 15, it will take away the data in an abnormal manner. So the impact is huge. How do we detect it? It is easier to detect missing value than detecting outlier. Because once you look at your file, you can easily see missing value in your Excel. You can easily see missing value. Oh, this is missing value. This dash. Oh, nothing is here. Or question mark. But for outlier, the number is there, but it's abnormal. So in that case, it's very challenging because another problem with outlier is what is an outlier in one variable may not be outlier in under another variable. For example, age 210 to 15 is an outlier for age column. The next column is total bursary received. Total bursary received by each student. Maybe they got bursary from their state government or any organization, NGO. Here you start having 12,000, 15,000, 17,000, even 200,000 sometimes. You know, here ordinary 210 value is an outlier under age. But under bursary amount, it is normal. You see, it is normal. Even 200,000 is normal. This is why you cannot just look at your data at random to say, oh, there's outlier in this data. So you need professional approach to be able to do that. And one of the easiest way of doing that is to use box plots. What we call the box plot. You plot, every column will be plotted against a system that will put them in the main. You see the data will be concentrated at the center. There will be one data that is now far away, maybe one or two data. They are far from the other samples. You know that this is an outlier. We can do that in Excel file. It's everywhere, box plot. The box plot will be able to reveal where is the outlier. Then how do we treat outlier? We treat outlier the same way we treated the missing value, the same method. The best method is to go back to the original source of the problem, where the data came from. Maybe you'll be able to get the original correction. The second level is look at the column. Is there any column with many outliers? You can delete them. The next is look at under that second one, look at the samples. Is there any sample that has outlier under different features? Then you can delete that sample, provided you have enough sample or provided you have enough features. But if your features are so few that you can't afford to delete anyone, the samples are so few that you can't delete anyone, then you move to the third option, which is to do what? Which is to do replacement. So you calculate the mean, you remove that outlier, you don't use the outlier to calculate the mean because it will affect the outlier. It will affect the value of your mean. So you remove that particular outlier tentatively and then calculate the mean of the remaining available value in each column and use that to replace the outlier. The fourth method for replacement that is often done for either missing value or outlier is to use prediction method. You build another model to predict the value that is missing. But that one will take a lot of time. You want to replace missing value, you have to build a prediction solution, a predictive model using machine learning. But some people go to that level to do that. So we predict what's the value that's supposed to be there. For either missing value or outlier treatment, we can use the prediction option. These are some of the options that are available for us in outlier. But don't forget, before you start, you can see that outlier detection is not something easy. So before you start doing this, first of all, use the original data. Even with the outlier there, run your model. Always follow that principle, please. Don't forget. That principle that you can always go back. Run your modeling, check the performance, go back, and then try to do outlier treatment, then run the experiment again until you are getting what you need. Because you may waste a lot of time on doing missing value treatment, on doing outlier treatment. At the end of the day, you found out that the original data, if you have modeled it directly, will have given you even better result than what you are getting. So speaking from experience. So always let the data speak. Another very popular pre-processing that people often also engage in is data transformation, like normalization, which is very popular in data analysis. You normalize the data. See, especially when the data is big, maybe column 1 is having very small number. Column 2 is having huge number. You can normalize every value to between, for example, the minimum, min, max, you specify the minimum and the maximum. I want the data to be between 0 and 1.0. Irrespective of the value. If your data is 20, 24, like the example I gave, the age, it will convert everything to between 0 and 1. If you have millions, billions in a column, it will convert them to between 0 and 1. So it forces everybody to obey the same rule of units. But sometimes, like I said, check the original data first, see if it's going to work for you. Normalization is a powerful method of transforming data, but sometimes it is not needed. It may even make you to miss the insight in your data. So always let the data speak. We have different types of normalization. We have the Z-score normalization, where you're going to specify how you want the normalization to be. Use this particular formula, and you score it in it to produce a particular number. And sometimes you normalize by decimal scaling. Divide the number by 10 raised to the power particular number. Maybe 10 raised to the power 2, 10 to the power 3. All the values. So they will all become to the same decimal places. This is under normalization. It's also another pre-processing you may need to do, but it's also optional. Yeah, we have so many other pre-processing, but at least, like I said, we can check out some of our videos online. Another very important concept I would like to talk about is feature engineering and feature selection. Again, you see it's featured here. These are some of the options you can always go back to, but let the original data speak. So in feature engineering, it is the science and art of extracting information from raw data. See, which information should we bring from the data? Feature engineering is a representation problem. So machine learning algorithm learn a solution to a problem from sample data. So in this context, feature engineering is asking, what is the best representation of the sample data to learn a solution to your problem? What's the best representation of that particular problem that will give you better outcome? So some machine learning projects succeed, while some fail. What makes the difference? The most important feature is used. If you use the most important feature, some features are there that they are not contributing. They are even bringing down your results. But you have to identify them. That is where the idea of feature engineering, feature selection comes in. Sometimes you may have to break down features, like date, break it down into 3. Day, month, year. Sometimes you want to combine them together. When the problem is so complicated, you have a lot of things. And this is where deep learning is very, very powerful. I told you yesterday, it has the capability to help you extract the features automatically. And after that, you can deal with what you have. Even at that, you can still also do feature selection on your feature that has been extracted by your deep learning. So deployment of feature selection is where to focus attention. The garbage in giggle is still there. Garbage in, garbage out. See, sometimes less is better. It's a universal problem of intelligence where to focus our attention more. If you have 15 features, maybe if I focus on 3, I may get better results than focusing on 15 of them. So feature selection is an optimization problem. You have this full feature. You want to identify the most useful one. I was able to run some algorithm, identify. So I now selected this feature. 4, instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Instead of 14 features, I'm now successfully using 4. Given a set of predictors, or we call it feature, V, and a target variable T, we are looking for minimum set of features that achieve maximum classification performance of T, or a given set of classifiers. If 4 can get me 98%, why should I use 14 that will give me 95? And this one will take me maybe 2 hours to run. And this one will take me like maybe 3 minutes to finish. And it's getting me better result. This is the idea of feature selection. So when your work is not going fine, you have used the original data set, this is usually the first place to look at. Can you check the features? And I will tell you a principle, what we call cost of dimensionality. Cost of dimensionality, this is cost. It's linear, it's not something good. The required number of samples to achieve the same accuracy grows exponentially with the number of variables. So as you increase the number of variables, the number of samples you need to get reasonable result will grow exponentially, not a very simple arithmetic progression. No. And that is the big problem. You see, this is the performance. If you have number of variables, you have one variable here, X, only one variable X, you can see your performance is here. Because the number of features, the number of samples is fixed. You see? Because in reality, number of training sample is fixed. We got a project one time, they had 50 features, and they gave us 300 samples. There's no way. We have to do feature selection. Because in a normal setting, for example, when you have 10 samples, when you have one feature, only X1, you need 10 samples to get reasonable results. But when you have 2 features, X1, X2, you need 10 raised to power 2, which is like 100 samples. Now, when I have X1, X2, X3, you need 1,000, which is 10 raised to power 3. So when I now have 15 features, that means I need 10 raised to power 15 samples, instances that I need to train and test my model. Now, the client gave me only 300 with 15 features. How am I going to do it? Let's look at this scenario. When you have only one feature, X1, you can see the 10 samples were able to fill each box. We divided the plane into 10 partitions. So if new samples are coming for testing, if it falls here, I know you belong to this class, this negative class. If you fall to this place, I know you belong to positive class. This is how classification works. One, without the training set, we get every training set to represent a particular O. So when new samples are coming, you see, it dump here, we know you belong to this class. You come here, you belong to this class. Now, when I increase the number of features to 2, X1, X2, and I still have only 10 samples. I have 2 features, only 10 samples like before. Here, I can achieve 99% accuracy, 100%, because for every partition, there is a representation of a class. But when I get to this place, look at how many holes. I have 100 holes now, 10 raised to the power 2. Out of 100 holes, only 10 has representative classes. You can see. So if a new class for testing falls here, we are confused. Is it negative class or positive class? We don't know. See, if we fall to this place, there's no representation there. So because the number of sample does not go ahead, does not go along to provide the needed representation. Now, when I have 3 features, X1, X2, X3, I'm expected to have 1,000 plus samples, but I still have only 10. Can you see? Look at several places that has no representation. So when new samples come here, my model will be confused. It doesn't know where to believe. If it comes to this place, it will be confused. It doesn't know where to push it because there are so many platforms there that has no representation. You see? If you get closer to this guy, okay, you may be able to understand it. This is what we call the cost of dimensionality. That's the number of features, the number of samples, instances. To achieve same accuracy grows exponentially with the number of variables. And anything that grows exponentially, you can't solve the problem. It's an NP complete problem. So when you hear exponential growth, run for your life because you can't undo it. Therefore, we need to solve that problem. And the good news is feature selection is a natural solution to cost of dimensionality. So the moment you have many features in your data, but the samples are not many, I've given you the hypothetical case. If you have 3 features, you should have like 1,000 plus or more. But often than not, they gave me 15 features with 300 samples. This 300 sample can only work for 2 features. Because for 2 features, I need 100. Anything after 2 features, I need more. I have to do feature selection. So the good news is that feature selection often solves the problem of cost of dimensionality. So that's it. So this is why we have feature selection. When you do feature selection, it can improve your performance. So it allows us to better understand the domain. It is also cheaper to collect a reduced set of predictors. Imagine if I build a solution for medical diagnosis and ask people to go and do 15 medical tests before they can use my AI solution. 15. To do 15 medical tests, you don't know how much somebody is going to pay. And another person was able to build the same application with better result. You just need to do only 2 tests. Which one do you think people will go for? Definitely people will patronize this. They will ignore this one. It's cheaper and easier, and it's also safer to collect a reduced set of predictors. When you reduce the number of samples you need, the number of features. For example, you want to do even ordinary questionnaire based. Some of my students working on predictive solution for medical intervention, you see questionnaire based system. When they recently developed their questionnaire. Some develop almost 17, 25. I said, these questions are too many. If somebody wants somebody to help you fill your questionnaire, you put too much question, they will not fill it. Or they just say, yes, 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 and go. Just to satisfy you. I said, reduce it to the BRS minimum so that people will be happier. Oh, how many questions? 10, 15, 12. Okay, we will help you. You have 50 questions for just simple diagnosis. You may not have people to fill it. And for somebody who is already sick and you ask me to go and do 50 medical tests, to extract blood for 50 medical tests from someone, you know what that means? Somebody who's already suffering from anemia before, is having not enough blood. You are again extracting too much blood from that person. So feature selection has a lot of advantages. So sometimes once you run your model in the original data and you are not getting good results and your number of samples are not many, quickly think about feature selection. And the next concept I would like to introduce also is evaluating the models. We discussed it a little bit before. That is, when you have the hypothesis space, we explained that yesterday. If it works for enough data, it will work on new examples. So how do we check that it is working? That's the generalization concept, which luckily we also described it yesterday. You have your training set upon which you are going to build the model, and then you have the testing set from where you're going to check if it is performing. And I also remember I explained this yesterday, how you divide into 2 or into 3. If it is to 2, you use this. If it is cross validation, thank God we already discussed it yesterday. For those here, you can check out the video. We discussed all this yesterday. Yeah, just to save our time. This is the 10-fold cross validation, also well described in our presentation. Now, this is where I want to quickly focus on. We couldn't do this yesterday. For binary classifiers, positive or negative, there were questions about this yesterday. It's not just the accuracy you are going to, I remember one question says, is it only the accuracy? No, you can't rely only on the accuracy. You need the confusion matrix. For two-class problem, binary, we call it binary classifier or classification problem. TP means true positive. That is, true positive means people that are positive and our algorithm has predicted them to be positive. True positive. False positive, they are those people, they are not positive, they are not sick, but the model mistakenly predicted them as positive. We call them false positive. That is, mistaken positive. True negative, that those that are not sick, negative, and our system predicted them as not sick. Excellent. We are praying to have many of these. We are praying to have many of these. We don't want to have this because it's a mistake. False negative is people who are sick but has been predicted as negative. False negative. Mistaken negative. We don't want this. But sometime in life, you cannot have 100% always. Now, so they now impact more than the other. If you are dealing with medical, false negative is a no-no. We don't want to tell somebody that he is not sick. Meanwhile, he's sick. He will go home and start enjoying himself, and then he will develop complications. However, so the cost of misclassification is huge when it comes to false negative. We don't want it. But false positive, we don't want any mistake, but sometimes if it comes, somebody who is not sick, you predicted that he's sick. You go to clinic for that check. Then they say, oh, we are sorry. Our system was mistakenly predicting that you are sick. Congratulations. We run many tests on you. You are okay. You can go home. This is we don't want mistake. You will have wasted the time of that person, but it's a mistake that is still manageable. You can manage it. But false negative, you have somebody who is sick. You say he's not sick. He will go home, enjoy himself, develop complication, collapse. Suddenly, the family can sue you to court as a medical center. Then the issue now comes. Is it the doctor to be sued or the AI that says you are not sick? There's no time to analyze that. That's the ethical and responsible utilization of AI. Who take responsibility of what the doctor that deploy AI in his own system? Now, we have to recall, you can calculate recall. Once you know true positive, this is the formula. True positive plus false negative will give you recall. Precision has formula, F major, this is the formula, and this is accuracy. Accuracy is the one we talked about most yesterday. It's true positive plus true negative, the correct classification divided by all the others. True positive plus true negative plus false positive plus false negative. So this is very important when you are describing classifier. Don't miss it. So this is it. When you report it, usually here it's showing us the actual in the real world. These are the positive. This is positive in real world. This is positive. This is the actual world. The true reality. The prediction is across like this. See, prediction goes like this. So when you have true positive, it is positive in real world. My algorithm has predicted it to be positive. Excellent. But for this one, it's originally in real world, it is positive. But my algorithm has predicted it, push it to negative. It's a mistake. This is the correct true negative. Everything in this row is negative. But now, some has been pushed to be positive by mistake. My algorithm predicted this to be positive instead of the original negative. This is how you look at it. So we give an example, but because of our time, predicted versus the actual, you can see here, when you look at for multi-class problem, when you have multiple classes, like DNA, ER, GIA, we have many classes. This is how you have the confusion matrix. You have, for this one, mistake, how many mistake here? So you can see the diagonal will show the percentage of correct prediction. This one predicted as this one, correct one. This one was mistakenly pushed to this, mistake. This one, 100%. Everything predicted as everything, as ER. This one, 100%. This one, mistake. This is the four mistake. This is correct. Diagonal show. That is when you have multiple classes. Okay. Now, so once you have this kind of example, this is the predicted value, this is the actual. Is there an error? There's no error. The actual is buy, don't buy. It's trying to advise if you should buy a computer or not buy a computer. The predictor say don't buy, but the actual is buy. Mistake. Yeah, it's a mistake. Buy, the actual is no buy. It says you should buy. Another mistake. So you calculate how many mistakes do we have. You can have this table. You can see this is the table. You have true positive, true negative. This is false negative. This is false positive. These are the correct prediction. 4 plus 3 divided by 4 plus 3 plus 2 plus 1 will give us the percentage times 100. We go for the actual percentage. So, but your environment weaker will give you the answer directly. So these are just example how we do that. So in addition to the accuracy, you have to check your confusion matrix. And remember, false negative is more challenging than false positive for medical. Let me explain that. You see, for medical, we don't want false negative. But for company that is using AI for predicting their quality control, after you are done with the system, you want to predict if the quality of control is excellent, is good or not. In that case, false positive is dangerous. False positive means you say the quality control is good. You send a product to a customer that is not good. So false positive, which we can manage in the case of medical, is not manageable in case of production companies because it will predict that the quality is good, and then you will send it to customer. Customer can take you to customer protection agency. You'll be in big trouble. In this age of social media, they can take your company online, Twitter, Facebook, and they start abusing your company that you are selling fake products. But false negative in the production company, it will say that this item is not good. Don't let it go. A quality control engineer will now check and found out that, oh, it is actually good. It was a mistaken prediction. It will now package it and send it. So you can see that false negative in the case of production companies is not acceptable. Sorry, it's acceptable. False negative is acceptable, but false positive is not acceptable, which is the opposite when it comes to medical. Because medical, you don't want to say somebody is not sick when he or she is sick. That is why we call it the actual cost of misclassification. So you have to analyze it. It depends on where you are actually applying the classification. So again, I recommend that we check out on our YouTube channel. This is an area we really explain a lot. And it's a confusion matrix. I don't know how the name came up. It could be confusing sometimes. You have to take your time and pay attention to it. And finally here, to the regression, I think we discussed regression yesterday. These are some of the mean square error, root mean square error, and other systems that we use to actually analyze and model the system. So then we gave the generic supervised learning framework before I believe at this point in time, we can switch to the next topic I would like to talk about because our time is a big issue. I would like to, now that is the general framework for the machine learning system we've learned. Start, data gathering, data preprocessing. I think we saw this yesterday. If you need, you can be going around until you are okay. Then you can do prediction with your model, analyze your result, which is very important. You need to write. This is the good thing about machine learning for data analysis. You need to write. You have to write the report. Even if you are not in academics, you need to generate reports. How did you do the experiment? So all those ones definitely will be dealt with in our track 2 for next week, where we're going to talk about how to use machine learning for reports, machine learning-based research development. So yeah, these are the general scheme that we have. Now, moving forward, maybe So we are going to now look into a brief introduction to ensemble. I want everybody to have a little bit of what is ensemble learning. This is very, very important. Sometimes, no matter how much you try, things may get really very challenging. You try all what you can, what you want, you could, but then you are not able to get the best result you are looking up to. So what can you do in that respect? So ensemble machine learning methods, combining models. So no matter how little, I need to introduce you to it. See, what is ensemble learning? See, an ensemble of classifier is a set of classifier whose individual decisions are combined in some way to classify new examples. It predicts the class label on previously unseen record by aggregating prediction made by multiple classifiers. The main principle is we group weak learners together to form one strong learner. So using multiple algorithms together for the same task, we can achieve better prediction than individual learning can do. It has been demonstrated in several real-life scenarios. See, I strongly recommend us. We have series of ensemble videos we've curated that will really assist you in our YouTube channel. I recommend us to check it out while we move on to a little introduction on it. Now, why does ensemble work? It's a decision of the crowd. Suppose there are 25 base learners, classifiers. Each classifier has an error rate of 0.35. So assuming that classifiers are independent, the probability that the ensemble classifier will make a wrong prediction is given by this formula. The lover of mathematics will solve it for us. This is what we're going to achieve. Imagine moving from 0.35 error per classifier to 0.06 for the group decision. And in reality, in January, when I had my inaugural lecture, one of the ensemble example I gave, we had 5 models, each of them performing to like 75% accuracy, 74% accuracy. When we added the 5 algorithms, the 5 models together, we achieved 100%. That is the power of ensemble. They usually perform better than individual model that you are combining. Why? Remember I told you yesterday, I said every algorithm has what we call hypothesis function, hypothesis space. So when you combine multiple algorithms, they're looking at the data from different angles. We're going to see it, actually. The motivation for ensemble, suppose that you're a patient with a set of symptoms. Instead of taking opinion of just one doctor, you decide to take opinion of a few doctors. Is this a good idea? Indeed, it is. A doctor should not just tell you, hey, you need knee surgery, and you start going for knee surgery. What if he's making a mistake? Get opinion of multiple doctors. Consult many doctors, and then based on their diagnosis, you can get a fairly accurate idea of diagnosis. Talk to as many doctors as possible, especially life-threatening surgery. Sometimes you may not need it. Then we have majority voting, which we call bargain. If 5 say yes and 3 say no, we go for 5. Sometimes we give more weight to the opinion of some good people. We call it boosting. Like you have a medical doctor with a professor of medicine with 30 years of experience. And he asks you, don't go for surgery. Only him. And we have 3 young doctors who are just learning, trainee doctors, and they ask you to go for surgery. We give more weight to the opinion of that medical doctor. We give him like maybe every year from a senior doctor is like 5 points. For a young doctor being trained, it's 1 point. So the 3 doctor will get 3 points against 5 points. So you still go for the opinion of the trusted person. So when a classifier is higher in performance, you give it more weight in contributing to the voting. But sometimes the professor also may make mistake, you know. Then that's why one of the best example of recent is the one we call stacking. We don't vote because voting sometimes either boosting or bagging may be disadvantageous. If a professor had problem with his family at home in the morning, he may be making wrong diagnosis, but we already assign him 5 points for saying yes or no. So we'll be multiplying the mistake of that trusted person. It happens in real life. Okay? So we have stacking ensemble solve that problem by making sure that you don't just vote, you train a model, the output from that model, you use to train another model that will give you the result. So how ensemble work? You construct a set of classifier from the training set and predict the class label of the test set using the aggregate of the decision. These are the features. You train 1, you train 2, you train 3. Now you let them vote. You let them do the voting. You call it the super classifier. Or it can be this. This is the voting. You have. See? You have, sometimes you can even use different version of your data. You train this with a sample of the data. The same data, you resample it. You resample it. Sometimes you might use 5 features here, especially when you have many features. You use 5 features here, you use 3 features here, you use another 4 features here. All of them, model 1 up to model M, they have a ballot box. I say yes. This one say no. Say yes. Then you do either bagging or boosting or the other method. This is how majority for several linear model perform. You have a model coming from, this is a linear model. We want to separate negative from positive. We run the first model, this one. It was able to separate this negative, but some positive are still missing with this, with positive. We trained another linear model. It was able to separate this one. Negative is out. Then it's still we have these ones missing with this one. Then we train the third one. Can you see the power of ensemble? We were able to get 100% performance. This one was able to separate this. This one able to separate this. While this one was able to separate this. Now we have 100% separation. That is the power of ensemble. Even with linear classifier, you can achieve a unique one. So sometimes when you are doing your modeling and you are not getting what you are expecting, maybe you have tried many options, it may be time for you to start considering ensemble learning. In principle, it has demonstrated that it's always powerful. You see that this very common example I used to give, Netflix, one time, they paid $1 million price. They want people to improve the baseline movie recommendation approach of Netflix by 10% in accuracy. The top submission all combine several teams. An algorithm as ensemble. You see, initially they couldn't win. It's a supervised learning task that you want to assign the recommendation to their films, how it should be. $1 million is not a joke. Many competition came. People put up a lot of things. Finally, the winning team, they were the one that combined the result of multiple classifiers. In fact, team 1 with many classifier, team 2 with many classifier, they brought their classifier together and they were able to win that 10% improvement, and they have their $1 million and they can share. That is the power of ensemble. A lot of ensemble demonstration in real life that has shown that ensemble is always better. Sometimes you may have to blend 107 individual model before you get the needed result. It's not a joke. So it's computationally very expensive, but sometimes it's worth it, especially when you work in a team. Let one team build 25 model, another team 25, then you can bring all of them together and see the power you're going to see. So, and this ensemble has been well demonstrated in real life scenarios. You see, when you want to learn, when you want to decide if this is okay or this is not okay, we've always demonstrated that it provides better outcome for us. So you combine the decision from different guys, so you can have the model combiner. Either you use bagging, or you use boosting, or you use the one I call stacking. Again, all these have been well documented in our YouTube channel. You can check them out. They are easy to follow rules. In real life, value of ensemble in real life practical demonstration. It has been demonstrated in many cases. How human ensembles are better than individual. For example, you are how many beans in a jar? You have a jar in front of you. You can demonstrate it at home. You see? And you want to make a guess. How many beans is that jar? Everybody make a guess. Then find the average of the guess. You see that the average is going to be closer to the number of beans in the jar. A lot of experiments have done that. Who want to be a millionaire? Expert friend or audience vote. People go for this competition. At last stage, they say, okay, this question is tough. You have the option of either asking the audience to vote or you call a friend at home. People call their friend almost get disappointed. Because you can only call one friend and the friend doesn't know it, that's finished. Audience vote always getting better result. And the one that I've demonstrated a lot in my classes, I usually ask my students to bring balloon. You bring balloon. What about having to identify balloon in a class filled with many balloons? On which names of owners were written? Do it individually or combine your efforts. See, they bring balloon the same color. Then I distribute it to the student. Write your name on the balloon. And then everybody submit it in the basket. And we shove it. We are going to pick your balloon. People take a lot of time. Some people, if there are 50 students in that class, there's possibility that somebody will pick 49 times before finally picking his own in the 50th time. They spend a lot of time. Chaotic. They couldn't pick it. Now, I say, okay, the control experiment. Everybody go to the, return the balloon now. Go to the place, pick a balloon. Don't look at it if it is yours. Pick a balloon, look at the name of that balloon, and give it to the owner of the balloon in the class. Within few seconds or a minute or two, everybody already gotten the balloon. That is the power of collaboration. When you collaborate, you get a problem solved faster than when you do it as an individual. And that is what Ensemble is saying. And that's the next area people are looking into in AI and machine learning. When every model is not able to model your data, the data is so complex, just remember you have an. And that's why I said, I will not forget. So you can see no free lunch theorem. There's no algorithm that is always the best in every situation. So generate a group of base learners we can combine as IR1. Look at it in real life. This guy is touching this an elephant. He said elephant is like a snake because it's touching. This story, some people say these people cannot see. You see, it's touching this place, this is a snake. This one say, no, it's actually like a tree stump. This one say, no, what are you saying? It's like a sheet of a leather. This one is say, no, it's like a little furry mouse because it's touching the tail. You can see this is how model work. When you use the decision tree on your data set, decision tree cannot see, it's looking at the data from its own hypothesis function side, hypothesis space. Another model is using it another side. Let them look at it from different angle. Hopefully, they will have a unified decision. You have model 1, model 2, model 3. Everybody is looking at this big elephant from different angle. From the other side also, let them now jointly decide what is this animal you are touching. That is how Ensemble gives you the global picture. Ensemble provides the global picture, and no wonder it has always provided better result than individual. Look at this practical example. We want to determine if somebody is a fraud, if an operation in the banking industry is a fraud or not. We developed three classifiers. This one say not a fraud, not a fraud, fraud. This random forest, logistic regression, KNN. So voting, majority votes. So 2 against 1, not a fraud. That's going to be our final answer. And if you train more than enough, like training like 105 model, you'll be sure that whenever you vote with this 505 model, the more the better. You are likely going to get the best result. But if you want to go by boosting, maybe this one, when after the training, this guy is getting 95%. While this guy is getting 65, I just getting 62%. We can give this guy 3 votes, and this guy 1, this guy 1. If guy say fraud, and this guy say no fraud, it will be 2 plus 2. That is 1 plus 1, sorry, this is 1, this is 1. That'll be 2 against 3 volts. Because we trusted this guy because he's getting better accuracy. We gave it more weight. That is called boosting. Sometimes it works, but sometimes maybe it's going to make mistake on the new samples. So that is why we have the stacking ensemble, which is smarter and always better than the other two we mentioned. That is, in short, what we mean by the ensemble. And then this is the example I was referring to. You can see this example. Look at this. This is the reality of the weather. We build a model to predict weather. Model 1, these are the mistake. It's making this mistake. It says it's going to rain, even though there's not going to be rain. This one says it's going to rain. It's not going to rain. This one made this mistake. Now, when we combine simple voting, majority carry the vote. 1, 2, 3, 4. We go for majority. 1, 2, 3. 3 against 2. We go for this. 1, 2 against 3. We go for this. You can see at the end of the day, the combined voting pattern is that this answer is the same as the original answer. You can see. So we got it 100%. Meanwhile, if you calculate, this one is making 3 mistakes. It's like 75% accuracy or even lower. This one, 3 mistakes, maybe 70 something. This also 3 mistakes. This one is making 2 mistakes. 2 mistakes. Because mistake here, mistake here. Despite the fact that they are far away from being 100%, we were able to get 100% accuracy from our ensemble. That is the power of ensemble. So when your modeling is not giving you what you are expecting, it is time for you to start looking inward. Maybe I need to build an ensemble model. I believe that is a good place to stop on the ensemble model. And yesterday, I told you that, we'll go to question time now. It's a very short time. However, yesterday I already showed to you where you can see where you can work on the ensemble. You go to classify, choose. You see here, this is ensemble. Where is meta? This is meta is the ensemble. So you can start with simple voting. This is stacking I was referring to. This will always work better. So we have practical demonstration in our videos already online. You can check them out. So you choose the voting ensemble. Click voting ensemble. See, in this voting, the first thing you do, you can read about it here more. It will tell you more about the voting, how it works. So here, you see classifiers. This is where you build. How do you want to combine it? Which combining rule do you want to use? You want to use average probability or product? Majority voting is what I want to use. There are different options. So what you do here is classifier. This is why you click that place and add your classifier. So here I'm going to add this is classifier number 1, IBK. That IBK, I want it to have K is equal to 1. Okay? I'll add it there. I don't want these zeros, it's added in error. So I add another one, IBK again, the same IBK, but this time around, I want to have K is equal to 3. K is equal to 3. Add it. I'm going to add the IBK again with K is equal to 5. Let's say these are the one you trusted. Add it. Now I have 3 classifiers added. I can now say, okay, close. I have 3 classifiers already inside here. And I already selected to use majority voting. So when I click it, I'll run it. It will build the classifiers and then decide for me based on how the classifier actually work. So this is how we build. You can see here now, this is the outcome of the classifier. If you see the model I built last, the result was 71%. But now I decided the same IBK I was using, now I decided to use voting. Look at what it has done. It took it from 80-something% to 90%. Just simple voting using K nearest neighbor with K is equal to 1, K is equal to 3, K is equal to 5. Imagine if I build up to like 15 or 25 or more. Remember, if you are using voting, it has to be odd numbers. So this is felt. We need to give you guys the time to ask questions and clarify. the case may be. Thank you very much for listening. Now we can take some questions if there are questions. Thank you very much for listening. And again, I strongly recommend. So I strongly recommend that. Yeah. So I really recommend that we check out the videos. Yesterday we already, that was shown to us. We have the video of yesterday have been provided for us, where I believe we demonstrated. But if we have some questions today also, we'll see how we can quickly run through within the few minutes that is available to us. But you can be right assured you are part of this learning group. Always you are welcome. Feel free, join our weekly programs. And we are also free to private chat me. It will be a pleasure for me to provide the necessary guide for you. If you need for us to log into the system, share screen and demonstrate things, I'm always happy to do that for my trainees. Thank you very much for listening. Now, I believe we can go to the question time. Thank you.
Thanks so much, Prof, for the wonderful session. Without wasting much of our time, the way we did it here today, please, those of our participants who have questions, please, you either raise your hand so that you'll be called, or you drop your questions in the chat box.
Okay, while those who want to raise their hand are still preparing, so let me quickly answer a few questions here on the system. Somebody is asking, said, how do we normalize the data set that contains both numbers and string features? Yes, for sure. So it depends on the kind of string features. Sometimes you have to do, for the string, you cannot normalize string like you are going to normalize numbers. You normalize numbers based on the example I've given today. It's their numbers. You can decide the kind of normalization. And in practice, I've seen that different normalization methods work in different problems. So that's why data analysis problem using machine learning is better done as a team of 3, 5, 7. The more the merrier. Because sometimes you need to try different procedures. That as an individual, before you are able to get it right, the insight you want to give to the company may be late, and your client will not like it. So you work as a team. While you are trying this, the other guy is trying this. Quickly, within few hours or days, you hopefully be done with your work. So, however, when you have string, there are some other platform you can use to manage your string. Sometimes you can code it. Yeah, but definitely you cannot undo numbers and string in the same way. But if the string are much, there are ways to use tokenization. Tokenization to see how you can actually work with coding your string inputs in your features. But you cannot undo it in the same way. They have a specialized way of handling that. Some of the string also work directly on the normal data without even any normalization. Like I said, it's optional. First of all, run the exact data before you start troubling yourself with all the preprocessing that are always optional. Some people treat it as if it's compulsory to do preprocessing. It's not compulsory. It is optional. Always note this. Yeah. Say, alhamdulillah, you're welcome. It's worth listening to the whole day. Please, I will plead for your hands-on practice, especially for people like me that are just starting. So yeah, you are welcome. I hope you attended yesterday. If not, the videos have been posted. I want to believe you can always check out the video. It's very, very easy to follow. We also have other videos on our platform that you can also check. I encourage serious practice. Don't just learn the theory, practice it, and by the grace of God, it will be great. Thank you. Yeah, and then, okay, and the question is for the coordinator. I said you should send the somebody wants you to resend the attendance list? Yeah. Okay. Okay. Anybody raising hand for question? Okay, there's no question. Okay, it seems there's no question. Let me use the opportunity then to show you one more thing. We still have like a few minutes. I have like 7 minutes more. Okay, Ali Olawale Abdrazak, raise up your hand. I will now let you can unmute yourself now and ask your question. Unmute yourself.
All right, sir. Thank you so much. I need to start by.
You're welcome.
Thank you, sir. Yeah, sir. I want to ask about how I can make use of the Weka application to do some analysis on the data already collected that already use the normal statistical tool we have. I mean, the SPSS package to work on. And with that, I was able to have output generated that was, that I included as part of the report for the research. So I'm wondering, because I've been trying to see how we can also work in that line based on what you've been teaching us since yesterday. And I think it might even give me better results. And for the hypothesis I want to, that I'm working on for the study. So, but the concern I'm having now is what I've mentioned earlier, how to output the results and maybe do some visualization of the data with graphs and all of that. So that is what I'm looking at now. I don't know how better I can do that.
Yeah, that's fine. Thank you. Thank you for the question. Excellent. Yeah, let's go dive into let's go back inside the Weka. Let's go inside the Weka. And we have Weka here. You see, yeah, you can do better things, just like you said. Yes, you can do better things in Weka than what you can do in SPSS. Like I said, the statistical method were the means of doing data analysis in the past. They are still using it today, but when the people discovered the power of machine learning, people started switching. The good news for you is all the work you have done in SPSS, you have published, bring them back. Use machine learning and compare it to them. And send it to the publisher to see what you are now doing. That's another very wonderful way to move towards utilizing machine learning. You'll be surprised at how accurate your prediction, your estimation will be. Yeah. Once you have your data, you have the pre-processing. For the sake of those people who may not be missed something yesterday on the live, bring in your data, bring in your data set. So let's say issues. I have data set already open. Let me use another new what do you call it, new explorer. So choose the file. I have my file. So again, when you want to choose your file, there's no file because it's looking for .arff. Try to choose CSV file. CSV file. So to bring it out. So let me bring out permeability. Yesterday we described more of classification. I want to bring up permeability data. Hopefully it works. Okay. Oh, sorry, this file is having a little issue. What could be wrong? Okay. Okay. We'll bring another data set then. Oh, software issue. Sometimes depend on the platform. Okay, let's bring in. Let's have here the database data. Okay, it's working on this. So it works quite in the same way. You see, once you select, you go to, now the data is in. The next thing is to go to classify. Go to classify. Select how you want to break the data down. See, this is my training data that is inside. I might decide to use 10-fold crowd validation. I want to break it down to 70 and 30% training. It's up to me. Because during the training, I want to do the hyperparameter optimization and the likes. That's up to us, whatever you want to do. So now the next is to select which algorithm you want to use. Our IBK, the one we described yesterday, you want to use it. You click. it's running for you. It's getting 90% at the beginning. Now, you can see here you are not getting your output. This is the question now. You are not getting the output here. See, you have to go here, more options. You now say output model training. If we need for training, we need for the actual prediction. I want you to put the prediction for me. Output prediction. So you choose the prediction, it will output it for you. How do you want to see the prediction? You want it to be in a CSV file that you can export, or you want it in HTML? Okay, let it be in plain text. I choose plain text, and I say okay. When I run it again now, you can see here there's no list of the data that has been predicted. I run it now again, then you see that it has generated the data. This is the data. These are the data. So you can then select it and take it out to your Excel and then start to analyze what you have gotten. If it is a prediction model, regression, you see here the same thing. You see the actual value here, and the predicted value will be in front of it. So you can then take it out and then make a plot in your Excel and whatever you want to do with it, because you can see the actual value that you are having. And also, you can also try it, okay, I want to visualize. You can also use visualization tool in Weka. See, you have to click it. You want to see the visualization from positive point of view or from negative point of view, depending on which one you want. Weka also has powerful visualization system that depending on what you want it to visualize for you. Is it the probability cost function, or you want the normalized, or which option threshold? You want to have the threshold, how it's performing. So is it the coloring you want to change? So many things you can do after having your result. Okay. So once you have your result, you can always right-click your model and then visualize the margin curve. Visualize if the margin curve you want to visualize. There are different visualizations that you can actually do, or you want to visualize the classification errors, how they behave and how they work. Is it gender? You want to see how they are behaving based on gender, based on another characteristics. So different visualization can be done. Then to another questioner, I can see there, it said, can we use deep learning? Yes, you can use deep learning. You can use deep learning. And for pre-processing here, before I leave the pre-processing, here you have filter. When you go to pre-process, this is where you can do your normalization. You can see filter. You can choose. Go to filter. You can see all filter. You can go to unsupervised filter. You can see the instance. You see, you can do a lot of things there. You can randomize. You can see the attributes. You can normalize it. You can see, you can normalize. You can see normalization here. Different one, you want to randomize it. So sometimes also you want to convert your data, nominal to string, nominal to binary. There are so many preprocessing you can actually carry out in Weka environment. For those who don't know how to do coding, it's a very wonderful environment you may want to explore more and more. And the good news is it has a very big community of people using it. Search for the community, join the community, and you can also interact with people who are also using it. And when you want to do anything, just ask your friend, Mr. Google. He will tell you how to do this in Weka. You will see the result for you easily. It's very self-explanatory and easier to use. That is pre-processing. Now, for the one person who asked about deep learning, you know, yesterday I showed you something about two in Weka. See, there are two here. I say package manager. You have deep learning. You have different, any package you want to use in Weka, you can't see it directly. Just go to the tool, the package manager, go here and search for it. Deep learning. Search for it. You can see it has Weka deep learning 4J. Weka deep learning. You have different versions. It started a long time ago. Now they already had latest version. If you want the latest, you choose the latest. And now you click install. If you look at my Wika environment. It was in my previous one, but the present one, I'm yet to add it to it. You see, it was not there. If you look at my Explorer, yeah, it will bring it and position it here. After visualize, you see it here, deep learning. So you go back to your package manager. You already have it here. Select it and click install. See, say the following package will be installed or upgraded. Okay, yes. Now, it's saying, please close any Open Wika application within Windows, Explorer, Experimenter, Knowledge Flow before proceeding. Do not see. So I need to close the Explorer for it to continue. Once I close those, except the manager except that will not close, I'll come back again and click OK and then install it. So you can use deep learning in Wika environment. And a lot of people are working with it and they're using it. So I believe those are the questions I believe we have for the day. And I strongly also encourage us, even if you subscribe to only this one, I encourage you to join us in the next week. That's highly encourage us so that you can actually learn more, see how you can write your report, even if you are not in academics. You don't need to be in academics before you know how to write your report. It also adds more to your knowledge. So thank you very much for the attendance, for coming, and we look forward to seeing you in our regular weekly learning platform every Saturday. So join the WhatsApp group so that you know when we are meeting. Sometimes if I'm traveling or have some commitment, we may not be able to meet. We usually announce before the date. Thank you very much once again for the wonderful time together. I wish you all the best. The resources will be made available. Check out other systems. You can even see it's already installing. It's installing in the background. You see, downloading, it will install it as the case may be. Thank you very much. We wish to continue on non-stop, but then reality is we have some other things also to look into. Thank you very much for joining us. God bless you all. Have a nice day. Bye. Over to you, coordinator. Anything for them?
Sorry, sir. Thanks so much, Prof, for all the efforts, and we also appreciate our participants for the patience throughout the 2-day training. We pray that whatsoever we have learned, may God make it beneficial to us and the society and humanity at large. That said, I slightly said by Prof that next week we'll be also meeting for the second track if you have registered.